Hello and welcome to 28th lecture of the course on corrosion, environmental degradation and surface engineering. Topic of this lecture is a life cycle impact assessment. And what do we do in this lecture? We try to figure out any system, product, how it is affecting environment, society and economy. There are the three major words: economy, society and environment. And that is why I am showing a kind of a worrisome face that it is too difficult to really wind up this complete topic in one lecture. But good thing is that there are ISO standards 14000, 14044 and 14040. There are two standards available where there is a systematic manner, everything has been documented how do we carry this kind of assessment. Further, we have a number of parameters and then comparison also available. So, we try to figure out whether our product is releasing carbon dioxide, how much energy has been released and what is really what kind of particles are really being released in environment, and equivalence will come directly from those data comparison, and there are some sort of softwares also available which can be utilized for assessing this kind of thing. Now, we will try to explore more, but let me say in slightly different word. We say the life cycle impact assessment, which is many times in the short form we write out the LCIA approach, is standardized framework. As I mentioned, it has been well documented and it has been given in number of standards also, and we will be discussing two standards in this lecture. So, it is a standardized framework to assess full cycle of the life of the product from extraction as a raw material to disposal, final disposal. Such approach is required, reason being that we have been talking about sustainability and we know that products should not harm the environment, and our course is also on environmental degradation. So, this topic is very relevant to our course. And then the question comes, how do I quantify material, how do I quantify energy and resources which are really required during the production, during distribution, during consumption or maybe disposal. Those things are really required in this case. So, most of the data will come from a manufacturers, and it is again iterative procedure, not necessarily in one go we can do everything. We have a number of documents available in literature we can compare. So, we really required how a systematic manner we should take this kind of approach. Then question also comes, what kind of the trashes will come out of this product, what kind of emissions will come out, or what are the byproducts. So, those need to be counted to really figure out what is the sustainability aspect related to that product. Now, as I mentioned, the trash production emission, which is really going to affect the air or water or land, which need to be accounted, and energy finally it is getting consumed by the product when during manufacturing, during usage, during disposal, those need to be accounted. So, these are the important aspects which are really required from a sustainability point of view. So, what we can say, LCIA is essential for promoting sustainable development and empowering companies, because we are talking about the MSMEs and we are talking about very small scale industries. So, they need to work on this kind of framework to come up to evaluate that what kind of product they are developing, whether that is correct or not, whether they are able to really score high, maybe say high in a sense from a sustainability point of view. In actual case score should be as low as possible, because the score is generally counted how much it is really affecting the environment. So, a product which affects minimum to the environment, that is more suitable from the emission point of view, from trash point of view, from wastage point of view. So, those things are important for us and we need to consider that. Now, we see the life cycle assessment we generally divide into 4 steps. What are the 4 steps? First is a goal and a scope. We decide what is our goal, whatever we are studying, what is our goal. It is a much bigger goal or maybe shorter goal, depends. Then what is the inventory analysis? So, what kind of raw material we will be using, what kind of energy we are going to give, is it renewable energy, non-renewable energy, maybe what are the emissions which are coming out of it, the SOx is coming, inox coming, carbon dioxide is coming, or some sort of hazardous materials are coming out of that. So, those things are need to be the figure out. That means we need to have some sort of balance sheet, what is input, what is output, and then based on that we need to figure out what are the impacts of those on the environment. So, this is very important, and everywhere we have used a double arrow, that means it is an iterative procedure. It is not a simple one linear relation. And finally, which is more and more important, is the interpretation. If interpretation we understand this aspect very well, interpretation will turn out to be very good. However, there are, as I mentioned, there are ISO standard, there are softwares also, there are very good case studies in the literature that those can be utilized. So, one of the case study is already there, that is what we are going to cover in the present lecture, which was published in 2019 in Materials. And then there says assessment of the environmental impact of a car tire throughout its life cycle. So, interesting thing in this case study is that tire, when we assume the tire is very essential, but tire continuously pollute the environment, not in only directly manner, that means it wears out, or maybe the leaves a particle in the air, it consumes energy, it consumes a raw material. So, it is really causing some sort of depletion one way or another way, but indirect way also, because it is really it can be used for the four wheel. In this case we are talking about the car tire. So, it is a four wheeler. So, four wheeler, when we drive the car, its average is maybe 6 and then we say the 6 kilometer per hour per liter, or 8 kilometer per liter. So, those things also been evaluated in this. So, how we can connect other products also, or related products with our system, that need to be also assessed from assessment point of view, or we say life cycle assessment point of view. Now, if I try to describe this, we say scope basically outlines the boundaries and restriction. What are the restriction on us? And then we say, yeah, we want to analyze in this way, because if you define these boundaries very well, then it can be established well, and then maybe when we launch a product, that can be described easily. Another one is that what is the target population, quite possible a rural population, maybe town population, maybe the developed city population, those things are important. And what kind of time frame, are we talking about 10 years, are we talking about 200 years, we are talking about 1000 years, those things are also important, because the long term everything may turn out to be very harmful as such, whatever development we are doing. So, those things are important, and then in which region this product will be more utilized. So, if there are more gains and lesser harms, then product will be success. If it is having more harms and lesser advantages, then product will not be successful. So, what we see in this case is scope is defined, then after that the goals, what do we really require outcome as such. Now, if suppose we want to improve the process, so now suppose I use some manufacturing process and I figure out that it requires a lot of energy as such, and then if there is other technology, I am trying to compare that technology with existing technology. I can say, okay, and the new technology takes lesser energy, so it is energy efficient, but takes some sort of, it gives more trash, or maybe gives some sort of negative output. Then I need to compare with that. So, there should be some benchmark, and that is why the life cycle assessment will provide overall benchmark. We can compare the two process with two product and maybe two different methodologies also. So, those things are important. So, what is our goal and need to be identified. Another one, as I mentioned very clearly, we need to really go ahead with the balancing of inventory loads, how much really we are giving and how much it is coming out. Output may be harmful also, it is not only the output is only useful, harmful, and the output will be need to be minimized as such. So, in this case what we say, inventory load, consider the input and output of the process or activity whichever we are using. By identifying and quantifying the loads released in environments, these loads can be anything as such. Now, here we are talking about the resources, and the raw material is a resource as such, then how much energy has been consumed, and as I mentioned, output can be functionality as such, which is really required from a product, but in addition it can be emission, it can be waste, which really finally requires a disposal, or maybe the kind of some sort of oil which need to be discarded every 1 year or every 6 months, that is also waste that need to be counted. And then those waste, this kind of output need to be, which are harmful to the society, need to be clubbed in some sort of categories. So, there are many categories. Now, one is a climate change category as such. Air pollution is a one category, water pollution is another category, resource depletion is another category. So, we need to grip on those things. So, whatever we collect as an input, we need to put in some sort of groups, so that we can really quantify. And as I mentioned, that when we are comparing the two product, two process or two methodologies, this kind of a comparison will be really very helpful to us. Now, coming to the life cycle assessment, what we are saying, as I mentioned in the beginning itself, how product process system will affect environment or entire lifetime. Now, this is one thing, entire lifetime of the product, but sometime we need to also look, see that even the product is not there, what will happen because of that after 200 years or maybe after 20 years. So, even after its life effect may be there. So, sometime that need to be also accounted. So, this is what we say on the over is a lifetime to forecast the future load impacts. That means how our environment is getting depleted. If we have all those calculations, we can really predict, and then we can really frame necessary policies. Now, in these days, what we are saying, that whenever there is a green energy, or maybe some product is a green product as such, a green manufacturing, those are more intense incentivized. Reason being, the taxation can be reduced much lesser on those compared to the product which are really creating more carbon contents, polluting environment in a bigger way. So, we can increase the taxation on that. So, this is very important, but I am just will be covering the example in the present lecture. Is something like, we have a small car and its average is around something like 20 kilometer per liter of the petrol, compared to the very big car, maybe luxury car, and the average is a 6 kilometer per kilometer, on the 6 kilometer per liter. So, naturally I will go ahead the smaller car far better compared to the bigger car, because average in this case is very high, but we need to really compare with the set parameter which are already documented. So, this is important, and then which product really should come in a market, and it will be very useful for the market compared to the product which is really creating more harm to the society. That should be minimized as far as possible. Those things are important, and then we need to think from policy point of view. So, what we say, the LCIA consider emissions, resources used, because we know that all the resources are what we say limited. We do not have infinity resources. So, resources usage is also important for us. Then it waste generation, whatever it has happened, and then during entire life cycle, even though I mentioned that sometime even we need to think beyond life cycle also. And these are this complete thing will vary from raw material procurement and then finally to disposal. So, this is what we really required, and then after doing complete analysis, what we are really looking, we are trying to identify weak spots. So, the more and more innovation is possible, and manufacturing process can be improved, materials can be improved, and maybe we want instead of 5 years life, then we go ahead with a 10 years life. What will happen? The raw material consumption will be reduced, energy consumption will be reduced. So, it is very useful, but what kind of material modifications are really required? So, those weak spots can be figured out from this, and then more after doing, we can really do some sort of innovation and then come up with a better results. Now, if I try to interpret what I mentioned here, so my interpretation, that's the fourth step also of this the LCA, is that interpretation in C basically involves a finding, identifying the primary contribution to the environmental impact, and considering uncertainties and limitations of assessment. What are the uncertainties? I really am thinking that this will take around 600 calories energy, but quite possible there is some sort of uncertainty. In one go I find 600, in the other go I find 800, and sometime I am finding 300. So, there is a lot of uncertainties. Those need to be accounted. Do we have a good measuring equipment? Are we able to quantify things properly? So, these are the important, and further there is a limitation, as we mentioned that scope, we need to really figure out what are the limitation, or maybe we are not we are planning to do things, but we do not have those kind of facilities available. So, those limitations also be accounted when we are trying to interpret the results from a source. Also another one is that we are able to figure out suppose a weak point or maybe the weak spots, and then we think about the improvement. So, this improvement analysis need to really look at the opportunities so the environmental impacts can be reduced, and that is what the aim of the course. Also energy consumption can be reduced, waste management can be very effective, our strategies can be really we seek the good strategies, so which really go ahead with a lesser waste in this situation. So, this is a very important, and finally whatever we are doing, it need to be documented well. If we are doing something and documented well, then it will bring more and more transparency and more chances of future development. If we take some judgment and we are not documenting, or maybe our interpretation is slightly different and we are not documenting, then the overall results will not turn out to be very good. As I mentioned that we need to stick to some sort of standards. So, in this case particularly one standard, as I mentioned, is ISO 14040, that is what we need to follow, and there is another standard also 14044. So, these standards really provide a framework for conducting whole life cycle assessment, and these are important. So, let us first understand what are these two standards which I mentioned. So, these are the literature available, ISO 14040, another one is a 14044. So, this is what we say the ISO, you already know, this is International Organization of Standardization, and then we have many standards, and then whenever we open and try to develop process or product, we need to follow standards. So, these standards, particularly these two standards, both the standards provide a guidelines for conducting life cycle assessments. So, this is whatever the topic which we are discussing, these two standards are really providing necessary information for those. However, their scopes are slightly different in the focus and the scopes are slightly different. So, first I am describing ISO 14040, second is ISO 14044. In this case, what we are trying to say that there is a framework for environmental management. Again this functionality we are not checking, we are assuming the functionality is a better as such, and then how this product is going to really harm the environment, that is what we really need to look into, we need to seek the necessary information. So, ISO 14040 is basically provides a foundations, and good thing is that 14044 is based on the 14040, right. So, this is this is the foundational standards that describes all the principles and the framework for the life cycle assessment. It really describes all the concepts, terms and definition whatever we are also discussing, but with more examples in those standards they have been described. And then in this case this standard divides a complete process as a four major thing. One is object and scope, inventory analysis, impact assessment and interpretation, which we described in previous slide. That these are the four stages. One is objective and scope definition, second is inventory analysis, third is impact assessment, and fourth is interpretation in this case. So, now coming to the next one, ISO 14044, it is also the environmental management related, it also really goes with the life cycle assessment. However, in this case what is more requirement, detailed requirements are given, and then even guidelines how to collect the data, how to analyze those data, those things are being given. So, this is a kind of slightly enhanced. So, this is standard 14044 provides some more information related to requirement, and then how to really go sequentially to conduct this life cycle assessment. Not only this, it also assures the quality and credibility of the LCA. So, whatever we are doing, it is really we are following all the norms. So, it will really show that this is a credible study, and then we should continue with this. That is why I mentioned that it really provides a direction for the data acquisition, data quality requirement and calculation method also been mentioned in this, and finally how to report these data appropriately, that does also be mentioned here. So, what we can say, it is a basically implementation standard. So, whatever 14040 is a fundamental standard, 14044 is the implementation of this standard, how to execute this standard. So, these things are already there in literature. I request you to please go through this kind of standards for the detailed analysis. Now, what we already mentioned that the 4 stages, and then we are talking about some sort of a data collection, and then when we get a data we really require some sort of a category of categorization of the environmental pollution or environmental related. So, there is a what we say that we need to think about what are the categories available, maybe something it will be causing some harm to the human beings, to the to environment, to the land, maybe water, to air. So, those categories are important, and whatever data we collect, those need to be allocated to the categories as such. Finally, those category we need to really go ahead with some sort of a characterization. We can give some sort of number 1 to 100, or maybe say 1 to 1000, or maybe some methods are really required for that purpose. And then once that's done, then we can calculate the score. Based on a score, we can really say which method is good, or maybe what are the weak spot and where the improvements are really required. Somewhat if you want to really go ahead with a slightly next stage, maybe slightly improve. So, what is a good point in the situation? What we have already learned, something like a normalization. All the data which are collected, if you do a normalization, it will really, maybe there are 13 parameters can be easily compared. And then if we go ahead with some sort of weighting factors, which we learn also weighted objective method, we can give a weight one way, and then the factor of higher weight compared to other, not necessary all they need to be equated or maybe equal weight for the each parameter. So, those things are also required. So, what we are saying, these are the mandatory elements and these are the optional elements. So, normalization is optional, weight is giving extra weight factors is the optional, and then we ensure that quality of the data are also really reliable, and then we do some sort of the mean value and standard deviation, those things we need to be calculated to figure out what is the really level of the quality. Something if I get a mean value 1 and a standard deviation 0.5, then it does not make any sense as such. So, naturally the quality of the data is not very good, but if I get a value 5 and a standard deviation 0.1, the quality of the data is very good. So, those need to be provided completely. So, more and more transparency will provide a better and better life cycle assessment to us. Now, whatever I mentioned, I am trying to write same thing. We say after organizing whatever the organized collection of the input, output and potential environmental repercussion, assessments should be considered, and then particularly for interrelated components. How the one parameter is affecting to other parameters, those things are also be considered. Then comes the potential environmental effects. We mentioned that we need to really define in a different categories. In this case, particularly the resource depletion is a one category, ozone depletion is another category, human toxicity is another category, climate change is another category. So, there are many categories in the literature which really and it can be utilized for all kind of products. So, it is not only for the metallurgy, this method is useful, or mechanical engineering, it is useful across various disciplines of the related to education. Even it can go for the any kind of industry, that the method is the same for the any kind of industry. Now, coming to the allocating input, particularly input and data whatever you are collecting to the right category, that comes into this, that is what has been shown in this case. Finally, we really need to figure out what are the indicators and then what are the benchmarks. So, like many times greenhouse gases are given comparison with a CO2 content. So, everything is green, every fact of the greenhouse gas is compared with the CO2. Something like methane has a 4 times more strong effect compared to the CO2. So, whatever the one unit load of the CO2 will be equivalent to the 0.25 load, maybe the equivalent to the CH4 is equal to 1 unit of the CO2. So, 4 times the CH4 is 4 times stronger, or fact is much higher, 4 times higher compared to the CO2. So, every times we try to compare with some sort of benchmarking, and some sort of indicators are really required. Even energy, whether we want to convert energy in kilowatt hours or megajoules, those things are important. Some sort of a toxicological potential, and then these are the basically required to convert all unstructured data to the right framework which are really required for the appropriate analysis and interpretation. More details are again given in this kind of literature, and then as I mentioned, the standards. Now, we try to mention clearly that initially that this product life cycle is basically we look at the data and energy, raw material and energy which will be consumed or may be taken during extraction of the raw material and the production or manufacturing time. So, this is the one. Then we really require some sort of the energy during the usage, and finally energy may be required during the disposal or whatever recycling is required. Now, we have expressed this in linear term: extraction and production to manufacturing, from manufacturing to usage to use to disposal. We are showing in a linear form, but in reality it is a highly non-linear, and then if we go with a good recycling or reconditioning of the equipment, then it can be cyclic also. So, ideally cyclic will be the best. Once it comes in a use, it should run without any failure as such. So, it will not be really harmful. That is ideally we believe in this manner, but quite possible if the tire is something we are even trying to repair in a proper way, but it causes more and more damage to the society, more and more carbon particles, or maybe that is another harmful for the breathing point of view. So, then we really need to replace it. So, sometimes the recycling itself may be a problem also. So, we really require this kind of a complete product life cycle assessment to figure out which step is really correct. Ideally, we say that recycling, reuse is a very good option, but if recycling itself is consuming a lot of energy, then what do we do? Right? If I am using making a new product with 1 unit of the energy and recycling requires 2 unit of energy, naturally I will not go for recycling. So, this is what we need to evaluate and compare. Now, what we are saying in this case, extraction and production, we require raw materials and then those can be gathered using mining. We know that most of the materials are extracted through the mining, maybe sometime the drilling, some sort of farming, particularly vegetation and all that can be used, and further they need to be processed, and then finally the products can be made from those raw materials. And then as I mentioned, the raw materials are turned to the finished product through industrial manufacturing process, and this manufacturing process can be categorized in number of ways. Here we are using the manufacturing as such. It can be forging, it can be anything also, and another fabrication can be the welding or maybe even riveting, those kind of thing, and then finally assembly. So, these all are the manufacturing related. So, manufacturing I am using the bigger set, and then these are the subset of the manufacturing itself. It is basically manufacturing the product, and then we can use the various manufacturing processes. And of course, everything need to be done as per the specification, as per the drawings which is being given. Now, another point comes where there will be some sort of wastage. Whenever we do manufacturing, there may be chip formation will occur, maybe some pieces will be broken, may need to be recycled. So, that is why the recycling also been accounted, and as far as possible the recycling, if it is done very efficient manner, then it will be useful. But if recycling is not done efficient manner, and then we are just using the word recycling without really looking into the input and output which are very useful to us, or maybe in a life assessment it really gives the energy losses are lesser, raw material requirement is lesser, and harm to the environment is lesser, then recycling makes sense, otherwise it does not make sense. Now, there is a diagram which has been shown here. We are saying that every product is we can start design and development based on the need requirement, whatever the needs are there. After this we go for the production, and then when the product is, we are showing that it can go through iteration also, modifications are also possible. Then if of the production, it should go for the fulfilling the needs use, it should be in a usage. Again we are showing that the two-way cycles, the product sometime customer give a lot of feedback and product is continuously improved. Then after this it can go for the the disposal or maybe sorting or maybe the disassembly, and then you keep good items out and then keep bad items for the disposal, and that is what we are showing here, that the post consumer product and post consumer product has been the 2 cycles. Now, here we are going for the reuse, recycling, and then now the new thing also comes like a repurpose. Repurpose is also there in this case. So, the things now everywhere you look at what we are showing that primary resources which are required and waste emission, everywhere we are showing that primary resources and waste emission, primary resources and waste emission. So, these are the input and outputs, what are the resources required in terms of material, in terms of energy, and what will be the emissions as such. We are assuming the functional product will be there, but apart from that what will be the emission which need to be accounted when we go ahead. And here, as I mentioned here, the after use it can go for the recycling or it can go for the waste treatment also, and the waste treatment it can be processed and maybe completely converted to the other form, or it can go for the landfill arrangement. As far as knowledge is concerned, we try to minimize or almost negligible landfill areas, and then waste and then should be repurposed, recycle or reuse as far as possible. However, the data show that is also not justifiable, then we need to look at either we close the product, we say that this kind of a technology is not very useful, better we look into the new technology. When we are not able to recycle, we are not able to repurpose, we are not able to reuse, then what is the point to continue that product, better we go for the new kind of product, new kind of technology instead of going for the waste treatment and then landfill area. So, these are the important for us. So, what we say in this case, on the end of useful life of the product, basically it enters into disposal stage. Line filling is a one option, incineration and other waste management procedure also are there, people are using, but now in these days because of sustainability point of view, we do not go ahead with that. Now, as I mentioned that we give more emphasis on reuse or repurpose. That is the same thing, can be repurposed for some other use, it will be very important. And then coming to the recycling, sometime we go ahead with disassembly complaint thing, and then we separate and keep the product in a maybe say 10% failures and then 90% can be reused. Those we can go ahead with this kind of thing. So, that is why we are saying collecting, separating and processing rejected material, so that new materials can be generated. Means after sorting we find only 5% components are bad and 95% components are right. So, we are going to again put back in a cycle. So, this is what we say cyclic manner. So, preferably, as I say, we are doing many time analysis of the linear process, but an actual is a non-linear process, and then if we can convert in a cyclic manner, that is the best. And that is why we are saying that re-enter the cycle, that means a cyclic process, that will be the best. When the reuse is a cyclic process, repurpose is a cyclic process, even recycling with whatever the modification, discarding little bit and maybe adding little bit, that will be the better. So, what we can say, the recycling conserves the resources and reduce environmental impact. So, this should be utilized, but not blindly. We need to do a life cycle assessment and then we can think about whether those things are correct or not. If I express it in my other word, we say LCA methodology consists of the 4 primary steps: goal and scope definition, inventory analysis, impact evaluation and interpretation. Inventory analysis entails compiling comprehensive data on input and output such as energy consumption, material flow, emission, debris generation. But because in the corrosion we know the debris will come out, where will we know that the debris will come out, even the fracture we say that debris will come out. So, those things are required. To quantify potential environmental impact, inventory data are evaluated using the impact categories, such as we use some categories, something like a climate change is a one category, human toxicity is another category, resource depletion is another category. So, we do a categorization, so that overall comparison turn out to be very good, because not every product can be used in same categories, but if there are well defined, suppose 17 or 20 categories, we can really compare easily products. So, interpretation concludes the analysis and presentation of the results, including the sensitivity analysis. I am bringing a new word here, and the sensitivity analysis, uncertainty evaluation and comparison with the alternative scenarios of the product. Here the sensitivity analysis also required. You can, if I am changing a little bit and then results are very good and favorable, can I really think about that, or maybe and then there is a some one or other parameter high sensitivity compared to others, can we go for the deeper understanding of that. So, this is really providing some sort of vertical thinking also. If there is something wrong, can we go ahead with a better analysis. Coming to the uncertainty, as I mentioned, that if we know really the mean value and the standard deviation, and the standard deviation is very high value, as I given a comparison, maybe the unit I have a mean value equal to 1, but a standard deviation is equal to 0.5. Naturally, I had to look at what is going wrong and then how do I improve evaluation method. So, these things are important when we go with life cycle assessment. And another one, as I mentioned, that the LCA can be used for the number of industries. It is not only for the only manufacturing or maybe construction or maybe energy production or agriculture, even the waste management itself is an industry. We can go ahead with the life cycle assessment of waste management method and then the processes also. So, we can say the LCA plays a crucial role in supporting eco design or ecosystem design, influencing the policy development, because most of the policies can be developed on that. As I mentioned that I compare suppose 2 tires, and one tire is really causing, even is relatively cost economic, maybe the cheaper price, but it is going to cause more damage to the environment. Actually, I had to maybe recommend for the closure of that product, or maybe go ahead with a higher taxation. So, it will really influence the policies as such. And finally, if we have this sustainability goal or maybe eco points available, then we can think about a sustainability certification or maybe labeling system. We can the way we have ISO standards, similarly we can really use some sort of a sustainability standards or maybe the labels that this is a good ecosystem, the product as such, it can be utilized in a better manner. So, those things are important. Another, I mentioned that LCA results really identify the opportunity to improve the product, or maybe say causes a more product innovation, it will causes a more sustainable alternatives material which are really required for in the society. So, basically if you look at what is a major issue why we are not very successful in LCA and of all the item is basically data. That how do we bring this data, and then how do we really interpret data using the appropriate modeling technique, and then finally what kind of expert opinion are really required. So, these things are important to understand. We really require data, we really require good interpretation, we really require experts, because nobody will be expert in complete LCA. It is a really multifunctional and many parameters are there. So, that is why we need to stick to the standards, we need to really follow the guidelines which are available, and for that purpose I am going to consider one case study where this all the standards have been followed, and with the addition of the one software, because if you 3-4 members, you cannot really evaluate LCA in complete manner. So, really require some sort of established standards or softwares which can really provide a good comprehensive evaluation. So, let us take one case study which as I mentioned very clearly that it is already available in literature. It was published in 2019, and this is a car tire. The car tire overall weight is around 10 kg, and then when you think about the raw material or maybe the inputs, in this case input category we have 2 things, one is a raw material, another energy. Raw material can be a number of materials, it's not only one material, it can be number of materials. Then comes what is our scope. Now, here the scope has been defined only in a few things, even though there is a raw material acquisition, then production, then use, then end of the life cycle or recycling, and then however there is a possibility of the disposal also. So, here however this paper has given this as a boundary, that this is my outline, these are the 4 steps only we will be going at. So, that means how the tires are going to get stored, they have not considered, what kind of a distribution mechanism will be there for tires, that is also not there. So, they have already defined that these are the scopes for us, even though in overall we may require a 7 step or 10 step, but our analysis is only based on the 4 steps: raw material acquisition, production, usage and end of cycle, end of life, particularly recycling. Now, instead of recycling, if you go for the disposal, naturally it is not been accounted over here. However, we will be considering few aspects on this. Now, what are the output? Even though we know that functional tire is output, right, but we are not accounting. Again, output also has been there. What are the atmospheric emission, what are the waterborne emission, what are the solid waste and other releases or harmful gases which are released to the environment. So, again they are putting the limits on output. Now, they are not considering in the infinity output as such. It will be indirectly also affecting other parameters, but has not been considered for this study. So, what the now coming to the raw material, they use a number of raw material. They use a synthetic rubber, of course the contribution what they are showing is around 24.17%, and the natural rubber they use, that is around 18.21%. Carbon black they use 19%. Now, in these days many people are thinking about using graphene as a replacement, that is one possibility, and then the steel wire they use around 11.4%, silica, oil, textile, zinc oxide, sulfur, stearic acid and recycling rubber. If you look at the recycling rubber, is only 0.5% weightage. So, what they have considered, they use a tire of the specification something like a P205, 55 or 16, and then they use the 3 indicators. What is the eco indicator 99, then another they use a CED, that is a cumulative energy demand, and last one is a IPCC, that is the Intergovernmental Panel on Climate Change. So, 3 parameters, one is eco indicator 99, the CED and the last one is the IPCC, and that is such these are the indicators which they have used for the analysis of the car tire to figure out whether car tire is really giving a the satisfactory results, or there are a number of improvements, and then improvement in which direction improvement should be done, those things are important. Now, what is really the tire as such? We know the tire is given a specification something like a P205 55 or R16. So, we know this P initial one is for the passenger vehicle. So, P means a passenger vehicle, then comes a 205, which is we know the tire width in mm. So, if the tire width in mm is a 205 mm, naturally the number is a 205. Then next comes the 55, that is what we say that is a percentage, the particularly the tire side wall is a percentage of the width, right. So, in this case the width was 205 and 55% of that is the side wall height, that has been mentioned. Then comes a R basically they are using a radial tire, or radial tire is kind of has an internal structure where the layers of the cord are arranged radially from the center of the tire. So, these are the specification for the tires. Coming to last, the 16, which is says the diameter of the wheel in inches. So, R16 is basically radial tire with a 16 inch. If I give full specification a P205 55 R16 means that the tire is a 205 mm wide, and it has a side wall height as a 55% of the width, and it is a design for 16 inch diameter wheel, and it has a radial construction. So, this is a complete thing. Now, coming to the eco indicator 99, what is that? Eco indicator 99, you say it is a method for assessing the sustainability, and maybe it provides some sort of a sustainability indicator, and then based on the life cycle assessment principles, eco indicator seeks to quantify potential environmental impact. It is really categorized in a number of categories. What are the resource depletion, climate change, ozone depletion, human toxicity, and there are, and in this present case we are considering 11 categories, and it combines finally all the scores in a single one, that is what we call eco points, right. So, if eco points on a higher side, that is a bad product. Eco points is a lesser side, it is a better product. So, we can compare the two separate product based on eco points. Another one was the CED, that is for the cumulative energy demand. It really evaluates that how much quantity of the energy really required. So, this is a total quantity of energy needed throughout entire life cycle of the product, process and service. So, this is a very important when we are talking the tire, how much energy is really required to make a tire, and then how much energy is really required for tire to run on a road, those things, and how much energy is really required to dispose of the tire. So, that all thing will come in a CED. So, that is why we say the comprehensive evaluation of the energy input at the various phases, including extraction of the raw material, production, transportation, usage and finally disposal. All this category need to be accounted in this case. And another thing is that it also consider direct as well as indirect energy consumption. So, electricity is a kind of direct consumption in this case, a fossil fuel which is really required for the usage purpose or some other renewable energy sources. Now, here if we know the manufacturing itself is taking huge energy, right, and then can we really work on to reduce the energy consumption? That is we kind of when we really document everything and then we know this portion is major and we need to be reduced. So, it basically gives a good brainstorming session, and then we can think about how to really reduce the energy input to for the manufacturing, how to reduce energy input for the usage of when the runs, that is when the vehicle's efficiency, increase in efficiency really will help us. So, energy inputs are typically expressed in this case is a megajoules or kilowatt hour. So, they are giving 2 units so that we can compare various options. So, energy input in this case has been given in a megajoule terms or kilowatt hours. Another one we say the appropriate, it need to be documented, and that too the document which can be read by everybody. So, appropriate transparent documents are important, and then whatever the calculation they have done or whoever is doing, what are the assumption that need to be documented, and from where they brought the data, on what databases they are using, and what kind of mathematical calculation they have done, what kind of approaches they have adopted, those need to be documented. So, eco indicator 99, then CED, and last one is the IPCC, which was established in 1988, and it is a kind of intensive source of information. So, this plays a critical role for scientific assessment and reports, particularly on climate change, its effect, possible mitigation and adaptive strategy. So, a lot of information can come from these sources. When we go through the IPCC, that we get a really lot of information, and then which was our major worry, from where those data will come, like from where the socio-economic effects will come, those things are there in IPCC. So, the primary object of IPCC is to apprise and synthesize most recent scientific, again every year they try to look at data and then try to improve it. So, scientific, technical, socio-economic data, as I mentioned, particularly in my the earlier time I felt a lot of problem, how do I quantify, how do I come up with the socio-economic effects and the socio-economic data that can come from this, ensuring a thorough and objective evaluation of the current status of knowledge. So, this is important. So, this kind of documents are important, these reports are important. Now, again comes to that these reports are based on exhaustive reviews of a scientific literature. It is not that somebody has just compiled, they go through the meticulous literature review and then opinion of several thousand of experts also. So, it is not that we get only the few experts and suggestion. Many people have given expert opinion, and based on that this scores have come, and then daily they provide a good kind of benchmark to compare our new development and then see how existing the scores have been established, and we can really figure out. So, these are the 3 primary important aspects, and in this tire case study they have incorporated all 3 parameters. So, let us see what data they have given to us. They collected all this data in the duration of the 1 year 2015 to 2016. You can see here the synthetic rubber, they have shown 1.928 kg has been utilized, similarly natural rubber, then carbon black and whatever, then how much water is really required is something they have given 36.112 liter, and then how much megajoule energy is required to fabricate one tire, that they have given around 828.896 or maybe roughly 829 megajoule. And then they use finally that finally by the discarding, when you want to discard the tire, it will be the final weight will be around 40 kg. And then if you look at recycling, then we may not require the kind of weight as such. Now another assumption, now we really require some assumption, as I mentioned, that everything need to be documented well. So what they use, that manufacturing process generated something like a 10 kg wheel, but they generate around 0.5 kg of trash as such. And then on average they consume 3000 liter for the life cycle of a 50,000 kilometer. That means when the car is running for the 50,000 kilometer, every tire consumes roughly 750 liter. So one car requires a 3000 liter and it has a 4 wheels. So on average each tire requires 750 liters of the petrol or maybe the gas, whichever in the vehicle they are using. So in this case, assumption is basically a traveler distance of 50,000 kilometer. That means after 50,000 kilometer, this tire will not be in a use, either it should be recycled or maybe the discard or go for the disposal, and then sometime the 50,000 kilometer is not been mentioned, then the life is a 5-year life cycle. And as I mentioned earlier, that they have not considered storage, they have not considered the distribution. So those data are missing completely, they have not done any cell check or maybe other, those things were not considered. Another one, coming to the disposal side, suppose if the tire is recycling of the tire is not really efficient, and then they need to really look at for some other method, and in reality the recycling of tire is not efficient, it is much more intensive and energy intensive. So to go for the disposal, they use some sort of burning and they try to recover the 40% of energy back, or they go ahead with some sort of a shredding, then it goes for the 38% of the energy back. Now when they go for the burning, they require maybe 0.06 kilogram of the fuel and then 0.06 the megajoule of electricity per tire to put it in a fire, and then can get energy 40% energy back. However, when they go for the shredding, they do a shredding in 2 stages. First is a 16 by 16 mm particle size, they consume roughly 7.4 megajoule of electricity and 1.5 kilogram of the water or liter of the water and some sort of oil for the shredding. They go for the next stage where they really require another 5.13 megajoule energy to reduce the particle size to lesser than 0.7 mm as such. However, if they want to go for some sort of a pyrolysis process, they require roughly 2.68 to 3.46 kilowatt an hour per tire, so which is not very on the high side. So depend on the finally what is really aim. Are we going for pyrolysis? Are we going for burning directly in a boilers kind of where they really require the furnaces and they can burn the tire directly, or they go for the shredding? Of course, emissions will be different in each case. So whichever case we are considering, that is why the scope, the boundary needs to be defined. What we want, what is our intent, naturally the emissions will be different in each case. And then another one, as I mentioned, that if we go with ISO 14044 standards, in this situation how to allocate the data particularly for each case, that will be defined. And in this case another one is that they assume that they do not, this case study which they covered in 2019 paper, they say that manufacturer have stick to all the norms, all the transparency is there. So they have not followed this standard 14044, but if you want you can go ahead. However, they did they collected the data using the directly manufactured data, but they did a data validation. How they did data validation? To validate, they use a energy equation, they use a mass balancing equation, and then they try to do auditing that not a single data is missing, nothing, no, it's not a mismatch or lost at all. So, if this balance gives proper results, then we do not have to worry. And then what we say, the energy audit and mass audit conservation is really important, and finally they can aggregate those data. Then what we say that this aggregated data are more fully in the useful thing for us, and we can really go ahead with a betterment. Now, what is the next stage? To basically look at the contribution, and then whatever the data which are coming out, what kind of byproducts will come out, and then either we do performance analysis on that, or we use some sort of software, and the software already knows that what kind of and the byproducts will coming out, or maybe what will be the emissions as such. So, they use SIMAPRO software as such, which they feel that is a well known software for life cycle evaluation, and then basically to investigate the environmental effect related to the automotive tires. So, this software is available and even you can try, it is available initially free, and then what kind of changes can be made in whatever the product we are trying to make. So, they say the SIMAPRO is a powerful solution who wants for the sustainable changes. So, environmental protection, to avoid environmental degradation, we really require sustainable product. So, they have developed based on some sort of algorithms. So, they have incorporated all those algorithms in this, and then they provide a good decisions, that is what they are claiming. And then they say that it will provide we say that in fact LCA approach provides insight, so that you go for the better and better decision, empowering better choice and reduce the environmental footprints, which is really the goal of this. So, this is the one software available, and maybe I am not covering this software as such in this present course, but when we go for the life cycle assessment, this kind of software can be utilized. It will really provide some results, and then if in industry they can buy it, it can be used for the academic purpose for some time. Now, coming to the overall data, the scores which really require, as we say, the eco indicator 99 can provide some sort of data to us, and then they have 11 categories. They divide those 11 categories in 3 categories, and what are those three main categories? One is human health, and then is ecological quality, and last one is resource depletion. So, these are the 3 categories. They divide everything in this. Of course, this is a one indicator. We use the word CED, where the energy balance will be coming, and finally IPCC, where we say that we have a very high rich data, scientific and an expert opinions are also available, so we can compare with easily. So, in this case, the human health, we know the human health we require some sort of respiratory related or carcinogenic impacts that can be related to human health. However, they also added a climate change, ozone layer depletion and ionizing radiation in the one, and then they now correct they express one parameter, that is a DALY, that is a disability adjusted life years to overall impact the what will be the impact on human health. So, DALY is parameters or factor or maybe the number which is related to human health. Now, coming to the ecosystem, so the whatever the emissions which are coming out from manufacturing usage of the system or product or component, that if really causing some sort of harm to the society, so we need to really figure out how it is really affecting causing harm to the ecosystem. Now, it is if it is causing a biodiversity loss, because in these days that is a very important term, that nothing should impact the biodiversity. So, if it is causing a biodiversity loss or it is causing a ecosystem health, that should be counted, and then there are 2 parameters to count. One, they use the word potentially affected fraction, that is what, that gives information related to the fraction of a species which are exposed to the dangerous compound or hazardous associated with them. So, it can be 0 also if the product is very good and then it is not really harming. However, we know that tire is causing some sort of harm to the society, and that is that the PEF will be counted. Another one is acidification or eutrophication damage, that is can be countered with something like a PDF, that is a potentially disappeared fraction. In this case basically vanishing of the items. So, one is causing a harm to the species, another one which causes a complete removal of those species from environments. So, these two factors are utilized for that purpose. Last one is a natural resource depletion. We know that we have a restricted or limited natural resources. Of course, this may change from one source to other source. So, in natural resources category indicates the surplus energy value in megajoules. So, whatever is left, that will be given in megajoule, and then as this energy is being consumed, we say remaining natural resource is only up to this megajoules. After maybe 1 year, this megajoule will reduce, for another next 1 year it will reduce. So, it can be used for the long term planning this method. So, these three indicators are accounted with eco indicator 99. Now, these are the data what they have given in this case. What they say, the life cycle inventory and the extraction of minerals, then they naturally wherever the process is done, that will be causing some sort of land acquisition or maybe usage. They this kind of material generate NOx, SOx and then ammonia. They utilize some sort of pesticides or heavy metals, CO2 and then HCFC, those things are also common, VOCs and then pH, and then coming to the what are the effects of this. We say that extraction of the resources, and then maybe some sort of impact on the vascular plants, acidification, that is what we use the word PDF parameter, toxic stress, PF parameters, climate change. Of course, this is directly related to the damage to the human health also, ozone layer depletion, ionization, respiratory effect and carcinogenic. So, these are the factors, and then what we say on this IPCC, which is basically Intergovernmental Panel on Climate Change, it provides a quantitative assessment of greenhouse impact, gas impacts, and then they give in terms of CO2. So, what we say basically the parameter is a global warming potential, and then what is a real contribution of each gas towards this kind of score, that is a GWP case, GWP score as such. And then this IPC gives values in terms of 20 years, 100 years, 500 years. So, that is basically long term plan, and then we want sustainable world, and in sustainable world those parameters are very important. And then as I mentioned, the eco indicator points are important. In this case, we need to convert whether the 140 points, 150 points, 160 point or maybe 50 points, lesser points will be more important, will be better for our overall results. However, as also mentioned that we need to really look at that the data which we are providing, what is the standard deviation with that, are the quality very good. So, let us take example. In this case, they have given the and then the score from 1 to 5, and then they have used the word uncertainty index. They say that uncertainty index is basically they estimate some results and measure. So, when and if there is a difference between this, so estimated results and equivalent measured values, whatever the difference, that will give a uncertainty. The lesser difference, naturally uncertainty is lesser side, uncertainty is more, naturally the difference, this difference is more on a higher side, and that happens whenever we go for the DQI lesser. So, DQI lesser is nearly provide a more uncertainty compared to that. So, instead of the uncertainty, they go ahead the DQI value, and then this the DQI basically defined on two parameters indicating minimum value 1 and max value 5. Higher DQI score shows higher data quality, improving greater trustworthiness or maybe say truth of this, while minor variation, so in this case only minor variation is here. So, they are assuming 10% deviation is minor, it is obvious as such, we can't estimate everything very accurately. So, 10% variation is tolerable, while coming to 50% is very bad, we should not go to this side. If we are able to keep high DQI, that is a very good for overall and then the life cycle assessment. Then now coming to this, they try to give a complete the LCA point based on the 1000 scores, and then they particularly then the whole study they have used a SIMAPRO software to generate all the histograms, and they initially they provided data in one table as such. I am just trying to show this case. You can see here they provided data in this manner. These are the more like a deterministic value, they are not going to change, while now when they go for this kind of software, they provide a minimum value and they provide a maximum value, and these values are different. Now when you use a software, you need to provide this data and maybe number of data point which you are using. So in this case they use 1000 points to give a data, and then based on that those data SIMAPRO program generates a histogram which we will be showing in the next slide for the different categories, what are the different impact categories. So this software itself provides a number of categories as such based on whatever the raw materials or products or whichever we are using are been given. Now here what is the difference? When we were using that time then the water quantity was only 32 or 36 liters, while in this case we are using the 40 liters. So the data have been changed to some extent when we are going for more and more detailed analysis. Now coming to this slide, they have 11 categories. What is the carcinogenic is a one category, respiratory effects are another one, then organic and inorganic, climate change, radiation, ozone layer depletion, exoticity, acidification, land use, minerals and fossil. Now what they are using, that this most of the environmental impacts are happening at the production level. So carcinogenic is happening only in the production level, radiations are happening only in production level, ozone layer depletion is also happening in production level, naturally land usage is also in a production level. So this category, now if they combine, so what are the overall points, environmental points here, they find around 141 points overall during the usage, while during process and the production points are not very high, and in recycling points will not be there. So in this situation recycling is a better option as such, but recycling is a very cost effective and then the cost intensive, and then need to be made more efficient per purpose. So this is what they have done. This is the third stage of the life cycle assessment, and then they did a grouping in different categories. Overall they divided in 11 impact categories, and then they found that when the tire is in usage, the maximum impact is happening because of the fossil fuel. So even though car engine is required fossil fuel, but tire are also related to that. If we make a tire efficient which consume lesser energy, naturally it will be far better. So this is and then finally it is coming out that in this situation the fossil fuel is contributing maximum level, and then should be minimized. And another one recycling, even though it gives a very good point, maybe almost 0 point, but we do not use that kind of recycling of the tire very efficiently, reason being that method or technology is not really efficient in this. We require a better and better technology to come up with a recycling. So I can summarize the whole complete lecture. We say in this we can identify using the life cycle assessment what are the impact of the product which we are thinking about. Particularly in this case we have discussed something from literature, one automobile tire, and then we say tire usage has a great impact, and it is reaching the almost 141 points cumulative manner, which basically the major contribution came from a usage. We say effect categories, fossil fuel contributes almost 66%, respiratory inorganics contributes 22%, and climate change contributes 9%. So these are the three main categories. So if we talk about the fossil fuel, this is a maybe indirect one, not direct one, but respiratory inorganics are important for us. We need to look at from a health point of view. Another one is the carbon dioxide. Wherever contribution they counted carbon dioxide in the climate change category, while coming to the sulfur dioxide, sulfur oxide and nitrogen dioxide, they have kept in respiratory inorganics. So, we need to minimize, if we do not worry about fossil fuel, we say it is an indirect one. We need to think about the sulfur dioxide minimization, nitrogen dioxide minimization. It may not be only the production, even the usage time, but it is happening because of the tires indirectly. So, those things are important. Another one, we say that life cycle mostly manufacturing itself is energy intensive and usage is also energy intensive. So, that should be minimized. If we do the work on that brainstorming and try to optimize the performance of the tire, we can really reduce this energy consumption. Energy recycling as such technique have a limited influence on minimizing the negative impacts of tire. Reason being, we do not have a energy efficient recycling techniques. As we say that it requires a 2-stage recycle and the shredding, and further we require more processing on that. So, what we say eco index of the manufacturer, usage and recycling of automobile tire or whole life was around 153 points with standard of the 37.2. This is another one. Now, mean value is 153 points, while standard deviation is also significantly high. So, we really require to go ahead with the better tools, and then to lessen the environmental impact of the tire, we require more energy efficient recycling system, and then second one, as I mentioned, indirect one, that is a reduced energy consumption and the riding time and manufacturing, which also consumes around 20% of the energy. So, we required more fuel efficient vehicle, as I mentioned, smaller vehicle, they are more fuel efficient. If it is there, then the taxation should come much lesser compared to the big vehicle which are not very fuel efficient, and then taxation should increase on those. So, these are the comparison, and then when we say that which product is causing more harm to the society, that should be accounted appropriately. So, this is a very good tool to compare the different materials, different products, different processes, and then come up with the right results, and it really gives a really initiation for the new innovation. So, thank you for attending this lecture. I hope this lecture will be useful to you. Thank you.